Hello viewers, I am Dr. R. Suresh, working as Associate Professor in the Department of Pharmacy, ANNAMALAI University. Today I am going to give lecture about HPLC, High Performance Liquid Chromatography. High Performance Liquid Chromatography is a technique, is an instrumental technique which is used to separate and analyze a given chemical compound. It is applied in all the fields of sciences like pharmacy, medicine, chemical engineering and agriculture. So, high performance liquid chromatography is otherwise called as high pressure liquid chromatography. In common man language, it is otherwise known as high patience liquid chromatography. Why we are calling this as high patience liquid chromatography means it needs lot of time and it needs lot of energy to do this experiment in the HPLC instrument, because when you think you want to separate a chemical compound, you cannot directly go to the lab and directly separate it, because it needs knowledge about the chemical under analysis. What is the compound you are going to analyze? You should know the basic nature of the chemical, its pH, its pKa and its dissolution and its solubility before going into the lab. Then selection of mobile phase. There are two phases used in the HPLC separation. One is mobile phase and another one is stationary phase. So, we should know the knowledge about their solubility to take the solvent as a mobile phase and select the stationary phase for separation of these chemical compounds. So, HPLC's main purpose is to separate and analyze a given unknown chemical compound. Okay. In this session, we are going to see about the introduction about HPLC, the basic principles of high performance liquid chromatography, the two different types of separation like normal phase HPLC and reverse phase HPLC, and their application in the various fields of sciences. Okay. First, we will see the introduction. What is the mixture of chemicals? A common man, as a common man, if you take any substance or isolate any compound from nature or any pollutant you are obtaining from the nature, you take to the lab and you want to analyze it, the only choice is you have to do instrumental methods of analysis. For that, HPLC is the main technique in which is used to analyze the given compound which is present in nanogram level also. So, that is the main aim of this HPLC. So, main advantage also. Okay. In microgram and nanogram also you can analyze the samples. So, introduction, the analytical chemistry deals with methods for determining the chemical composition of samples. It is of two different types: qualitative analysis, that is for identification, and quantitative analysis, that is quantitatively the exact amount or concentration you can find out. So, qualitative analysis and quantitative analysis. Instrumental methods of analysis and their Nobel Prizes. Many scientists have been rewarded with Nobel Prizes. In 1964, Dorothy Hodgkin won Nobel Prize discovering the structure of vitamin B12 and penicillin. She did this by using the instrumental technique called X-ray crystallography. Why I am saying this example is, lot of Nobel Prizes have been won by the scientists by using the instrumental methods of techniques for the analysis of biological samples. So, Dorothy Hodgkin was the one who found out the vitamin B12 structure and penicillin structure using X-ray crystallography. She later used the same technique to investigate other biological molecules like cholesterol and insulin. Without her work, other works like Hodgkin's or our fellow scientists would not have been possible without X-ray crystallography. Some of the Nobel Prize in the field of chemistry like John Fenn, Koichi Tanaka and Kurt Wittroch, one of jointly by John Fenn and Koichi Tanaka for their development of soft desorption ionization method by mass spectrometry of biological macromolecules, and the other half of the Nobel Prize is given to Kurt Wittroch for his NMR spectroscopy development for determining the 3-dimensional structure of biological macromolecules like insulin in solution. The Nobel Prize in Chemistry in the year 2014 recently was awarded jointly to Eric Betzwig, Stephen W. H. Hell and William Morner for the development of super resolved fluorescence microscopy. So, in the field of instrumental methods of analysis, lot of Nobel Prize have been won by the scientists. So, this slide shows the types of instrumental methods like spectroscopic methods, atomic absorption spectroscopy, molecular spectroscopy like UV, ultraviolet spectroscopy, Fourier transform IR, infrared spectroscopy, NMR and MAS. And the second one is the chromatographic methods, which we are going to see today, HPLC and gas chromatography, etc. And the third one is electrochemistry, which deals with the potentiometry and conductometric titrations using electrodes. This slide shows the block diagram of an instrument, any instrumental method of measurement of the stimulus under study. We have to supply energy stores, which is the stimulus, which is absorbed by the system under study, that is the chemical under analysis will be which will absorb the stimulus, and the remaining amount of the radiation will be coming out of the sample is recorded as responses by various detectors, which are used for identification of the impulse which is coming out of the system under study. Application of instrumental methods, these are the wide bioanalytical, they have bioanalytical applications in the field of biological molecules and or biological matrices like proteins, amino acids, blood, urine and pharmaceuticals. Mainly used in the environmental science like pesticide, to analyze the pesticides, pollution control, air, water and soil pollutions. Material science like polymers, characterization of new materials, and also in forensic science like application of science to the law, body fluids, DNA, gunshot residues, hair, fibers and drugs, alcohols, poisonings and fingerprints, etc. Selecting an analytical method. How will you select an analytical method? Before knowing the nature of the chemical, how will you select? In order to select an analytical method intelligently, it is essentially to clearly define the nature of the analytical problem. In general, the following points should be considered while choosing an instrument for any measurement. Accuracy and precision required. What type of accuracy and precise result you need? It depends upon the nature of the substance which is present in the unknown sample. So, how accurate you want to analyze the sample and how precise you should analyze it, that should be known. Second point is available sample amount. If the sample amount is very low, you should go for HPLC only. If it is very much large, you can go for UV and IR or NMR and MAS. If it is very low, the available sample is very low, the only choice is HPLC and LCMS, hyphenated techniques like LCMS techniques like. And concentration range of the analyte. How much concentration range is needed for analyzing the unknown substance? Concentration range like 0.1 to 0.5 microgram or 10 to 50 microgram per ml concentration of the analyte available. So, next is interference in the sample. So, the sample preparation is needed when you analyze the sample in the HPLC. When you mix the sample with the mobile phase, there is a interference is occurring, means you cannot use. So, before going for the analytical method selection, you have to know the interference of the sample with the mobile phase and the solvents. Physical and chemical properties of the sample matrix, as I said earlier, pH, pKa and solubility, these parameters should be known to the analyte should be known for the analyte under study. Number of samples should be analyzed. If the sample number is more than 20 or 50, you cannot go for HPLC. It is an highly costly and cost effectiveness is not there in the HPLC. So, that time you have to go for UV. So, number of samples also affect the selection of analytical method, and the speed, ease, skill and cost of analysis. These are the points you have to take into consideration before selecting an analytical method. Modern chemists use a wide range of instruments to analyze and identify substances. Most produce quantitative data which requires expert interpretation. There are many different types of machines used for analysis, each producing a different types of information, such as whether a substance is pure or a mixture. That is, by HPLC you can find out whether the given unknown sample is a mixture or a pure sample, and HPLC, GC, HPLC is used for whether the given sample is pure or a mixture. You can find out. The molecular mass of the compound is found out by mass spectrometer. If you want to know about the bonds, double bond or triple bonds, you have to go for UV visible spectrophotometer. If you want to know the arrangement of atoms in a molecule, you have to go for FTIR, NMR and X-ray. If you want to know the isotopes of different atoms in a substance, you have to go for nuclear magnetic resonance spectroscopy, NMR spectroscopy and ORD. Now come to chromatography. Chromatography means color. Chrome means color. It is a technique used to separate and identify the components of a mixture. So, in a given mixture, there will be a one or two or more substance will be present. So, by using color separation, you have to separate it into 1, 2 or 3 or 4 or 5 different compounds, and you have to identify what are those compounds present in the unknown sample. So, chromatography is used for this separation and identification. It allows by it works by allowing the molecules present in the mixture to distribute themselves between a stationary phase and a mobile phase. Molecules that spends most of their time in the mobile phase are carried along faster. So, mobile phase, as the name implies, the mobile phase is the moving phase or the eluent, and the stationary phase is the stable phase which does not move. So, the sample which is dissolved more in the mobile phase will be eluted faster and will get separated faster, and it will be identified faster. Chromatography is first invented by Michael Sweat in the year 1901 during his research on plant pigments like chlorophylls and xanthophylls and carotenoids. He is a Russian botanist. He is born in 1872 and died in 1919. So, he is the one first discovered chromatography. Michael Sweat experiment is based upon a column chromatography. The column is filled up with calcium carbonate and chlorophyll is placed over it, over which ether is poured. The ether will separate it into 3 different colors. So, the 3 different fractions will be collected and it gets separated and identified. What are the separated compounds are green color is chlorophyll, yellow color is carotenoids and xanthophylls, red color is xanthophylls. This is the first one invented by Michael Sweat. Comparing the chromatography to the flow of river. Why here we are comparing the chromatography with flow of river is stationary phase is compared to the soil in the river bed, which is the base, and the water it is flowing over the soil. When leaf and heavy stone is present in the river, heavy stone will have more attraction towards the soil and will not move faster, while the light leaves, which is lightweight, which moves along with the river water, which moves faster and gets out first or comes out first with, from the stationary phase and eluted faster and will get separated faster. Mobile phase versus stationary phase. Having the mobile phase is the liquid generally, and the stationary phase is the solid generally. In case of chromatography, there are 2 types of chromatographies are there: liquid chromatography, gas liquid chromatography and liquid chromatography, solid liquid chromatography. The stationary phase, when the solute have more strong affinity towards the stationary phase, it moves slower. When the affinity towards the stationary phase is weak, it moves faster. 3 states of matter and chromatography types. So, stationary phase is a gas, liquid or solid. Stationary phase cannot be a gas. The mobile phase can be a gas and can be a liquid. So, that time when the stationary phase is a liquid and the mobile phase is a gas, it is called as a gas chromatography, and when the stationary phase is a solid and the mobile phase is a liquid, it is called as a liquid chromatography. The liquid chromatography is the one which we are going to do, which we are going to see in this session, high performance liquid chromatography, HPLC, which is otherwise called as high pressure liquid chromatography. Liquid chromatography, in which the mobile phase is the liquid, which is otherwise called as the eluent. The stationary phase is a solid or a liquid. In general, it is possible to analyze any substance that can be stable dissolved in the mobile phase. As I have said already, when the unknown chemical should be stable in the mobile phase, which you are going to dissolve the mobile phase. Interaction between solute, stationary phase and mobile phase. When the stationary phase is having more attraction towards the solute, it will get, the degree of absorption will be more, it will get slowly eluted from the stationary phase. When the mobile phase is having less affinity towards the solute will be eluted faster. So, the difference in the interaction between the solutes and stationary phase and mobile phase is shown in this figure. Separation process and chromatogram for the column chromatography. The three different colors, red and blue. Red is having less affinity towards the stationary phase, so it comes out first, and the blue is having more affinity towards the stationary phase, which comes out later. It is a typical chromatogram, and this is the flow channel diagram of the high performance liquid chromatography, in which we have two phases, as I have said earlier, mobile phase and the stationary phase. Mobile phase is present in a reservoir, which is otherwise called as an eluent, which is attached to a degasser. Why degasser means, if you are passing the mobile phase with gas bubbles, it will block the tubings of the high performance liquid chromatograph. So, that time pressure difference will be developed. If pressure difference is developing, the separation will not be efficient. So, degasser is attached to the reservoir having mobile phase, and then the mobile phase is passed upon to the pump, where high pressure is applied, 1000 to 5000 psi, parts per square inch pressure is applied, and from there the sample injection unit is present, through which you have to inject your sample through syringes in micro ml, microliters, 10 microliter or 20 microliter injector is present, and after that the mobile phase carries the sample under analysis to the column oven. Inside the column oven, the stationary phase is present, which is called as the column. The column is a material which is made up of C18 and C8, octadecyl and octyl silane. So, the sample which is carried by this mobile phase from the sample injector port will enter into the column. The column will be present inside a thermostatically controlled column chamber. Why we are using a thermostatic controlled column chamber means, the volatile samples may be volatile under high temperature or room temperature. So, that time that a thermostatically controlled column chamber is used, automatically maintains the temperature below 10 degrees or 15 degrees. Sometimes the mobile phase will be evaporated at higher temperature. That time you need higher temperature should be lowered by automatically controlled thermostatically controlled chambers. After once the mobile phase along with the sample comes out of the column, it enters into the detector. The detector used in HPLC or various detectors are used, which depends upon again nature of the sample under study. So, if the sample absorbs UV radiation, you can use UV detector or PDA detector, photodiode array detector, which scans the entering wavelength from 200 to 800 nanometers. Some substance which possess refractive index may be detected by refractive index detectors. Some other substance which have chiral detectors, chiral in nature, like R form and S form, chiral detectors are used. So, once the detector is detecting the sample. It will be integrated with a data processor or a computer which records the signal as a chromatogram. Chromatogram like first peak, second peak and third peak will be eluted and will be recorded in the computer. The sample along with the remaining mobile phase will be come out of the detector and will be collected in the drain. The drain is the place where the sample plus unused mobile phase is collected, and it should be carefully handled and it should be thrown out carefully. It should not be thrown out in the dustbin or in the drainage directly, because all the chemicals which are used in the HPLC like acetonitrile is carcinogenic. We should take it very carefully. We should take care of those drain, and it should be carefully, it should be thrown out. Okay. Guard column and pre-column. The use of pre-column is to avoid any microparticles or macroparticles present in the mobile phase which is entering into the sample injector, and the guard column is used to prevent the column. The column is highly costly, which is starting from 20,000 rupees to 1 lakh or 2 lakh rupees. So, to prevent the column, main column, we are using guard column. Guard column is made up of the same substance in which the main column is used. Guard column is used to prevent the impurities present in the sample from entering into the main column. Okay. That is the use of guard column and pro column. And next one is the chromatogram, which is obtained in the computer, is like this, and T0 is the non-retention time or the noise peak, base peak, noise peak of the baseline. TR is the retention time. Retention time is the elution time which takes for the sample to come out of the column. Retention time. Area is the A is the area, peak area, and H is the height of the peak. From liquid chromatography to high pressure or high performance liquid chromatography. What is the difference between liquid chromatography and high performance liquid chromatography is high degree of separation. The resolution is high. The separation between the two peaks will be clear, and the baseline separation will be exactly defined, well defined. Refinement of the packing materials, that is the column material packed with the silica gel is 3 to 10 microns. So, the separation will be more efficient, and reduction in the analysis time. Normal chromatography, the analysis time may be 20 minutes or 30 minutes, but when you use high performance liquid chromatography, within 5 minutes you can analyze the sample, same type of samples. Delivery of the eluent by pump, demand for special equipment that can withstand high pressures. So, thus arrived the high performance liquid chromatography. These are the advantages of high pressure liquid chromatography: high separation capacity, enabling the batch analysis of multiple components, superior qualitative and qualitative capability and reproducibility, moderate analytical conditions. Unlike GC, the sample does not need to be vaporized. In gas chromatography, the sample need to be vaporized. So, if the sample is vaporized, it gets unstable, it gets changed in the chemical nature. So, this is the advantage of HPLC, where we are not vaporizing the sample, directly we are injecting the sample into the high performance liquid chromatography. Low sample consumption. If microgram or nanogram level of sample is present, we can easily use for analysis in the HPLC. Easy preparative separation and purification of samples. Isocratic and gradient elution. Isocratic means same solvent we are using throughout the separation, and in gradient we are using different types of composition of samples. For first 10 minutes we will be using 50% of methanol, and for the next 10 minutes we will be using 40% of methanol. So, high pressure and low pressure gradient, two types of elution systems are present in high pressure liquid chromatography. In isocratic mode, long analysis time is taking, that is 60-40 methanol and water, and in poor separation, because only one type of solvent we are using, methanol and water, the separation is very poor. You can see there is no baseline separation is present in the chromatogram. the column which is used is ODS, octadecyl silane type. So, here the chromatogram of the gradient system, in which the mobile phase is continuously changing as the time changes from 30 percentage to 95 percentage of methanol. So, here you can see well resolved peaks, 1, 2, 3, 4, 5, 6 peaks are present, well resolved and well separated peaks are obtained in gradient system. So, always we use gradient system rather than isocratic mode. HPLC separation modes is based upon the two different types of principles like adsorption and partition. Partition is based upon normal phase and reverse phase partition chromatography. Other than that, ion exchange chromatography and size exclusion chromatography is also the principles of HPLC separation modes. Partition chromatography, a liquid or a solid, a substance regarded as a liquid is used as the stationary phase, and the solute is separated according to whether it dissolves more readily in the stationary or mobile phase, liquid chromatography. So, these are the various non-polar functional groups and polar functional groups examples. So, alkyl groups and phenyl groups are non-polar, polar functional groups are carboxyl groups, amino groups and hydroxyl groups. Depending upon the normal phase and reverse phase, the stationary phase is normal phase. You should remember this one, reverse phase, high polar mobile phase is used. So, automatically opposite, the stationary phase will be low polar, just opposite to that normal phase. Stationary phase will be highly polar and mobile phase will be low polar. You should remember any one. In reverse phase, the mobile phase is high polar, like methanol, water we have to use, acetonitrile we have to use. Reverse phase chromatography is the widely used chromatography technique in pharmaceuticals and chemical analysis. Why? Because it is cost effective and less time consuming. Stationary phase is low polar, octadecyl silane, mobile phase is high polar, water, methanol, acetonitrile, and sometimes buffers like salt is used, ammonium acetate buffer, sodium acetate buffer and potassium orthohydrogen orthophosphate buffer is used. Non-polar functional groups and polar functional groups like alkyl groups and phenyl groups is functional groups, normal non-polar, and polar functional groups like carboxyl group, amino group and hydroxyl groups. So, this is the column material stationary phase like octadecyl silane. You can see silicon is bonded with octadecyl ODS column. ODS, octadecyl means 18 CH2 groups are attached to silyl group, C8 octyl group, C4 butyl type, phenyl type and TMS type, tetramethyl silane and cyanotype columns are used in reverse phase chromatography, which are less cost effective. The cost of these columns are around 20 to 30,000 only, whereas in normal phase the column which are used are phenyl type or other types are used, which may be around 1 lakh or 2 lakh rupees. So, cost effective separation is done by reverse phase only. Relationship between retention time and polarity. So, in reverse phase chromatography, octadecyl silane will be having weak interaction with the polar functional group like phenol. So, it will be eluted first, and when the strong bonding between toluene and the octadecyl silane will be eluted faster. Basic settings for eluent used in reverse phase chromatography: water along with buffer. The buffer may be potassium dihydrogen orthophosphate, potassium hydrogen orthophosphate or sodium phosphate or ammonium phosphate buffer plus water soluble organic solvents like methanol, acetonitrile and THF, tetrahydrofuran. The mixing ratio should be done by trial and error method for separation, and the pH should be maintained depending upon the pH of the sample under analysis. Relationship between polarity of the eluent and retention time in the reverse phase mode. So, here you see in the first chromatogram 60:40 methanol is to water is used, the retention time is around 10 minutes, whereas in the second chromatogram 70% of methanol is used. We are increasing the methanol ratio 70 percentage. So, the retention time is reduced further to 6 minutes, and if you reduce further, increase the methanol ratio 80 to 80, it reduces the retention time to 5 minutes. So, almost 50 percentage of the time is consumed if you increase the methanol HPLC grade methanol, and HPLC grade water is used in 80 to 20 percentage ratio. Buffer solution generally used are high buffering point at the prescribed pH. It should not affect the detection, does not damage the column or equipment, and it should be inexpensive. Why I am telling here, the main point is that the buffers, when you use inorganic buffers like ammonium acetate or sodium acetate or potassium dihydrogen orthophosphate or phosphoric acid, acetic acid or citric acid, these are all inorganic buffers. When you get mixed with organic solvents, it gets precipitated in the column. So, once it gets precipitated, it is difficult to remove from the column, and the column will get damaged. And not only column, the tubing will also be deposited with the inorganic salts, which blocks the tubings of the HPLC system and causes increase in the pressure and decreases the efficiency of separation of the samples. Normal phase chromatography, which we generally will not use in pharmaceuticals or other fields, but when you want to find out the isomer separation, we have to go for normal phase like R isomer and S isomer, rectus and sinister, R androsterone, S androsterone, or levocitrazine, dextrolevocitrazine, cetirizine and levocitrazine, we have to separate, we have to go for normal phase chromatography. So, partition chromatography, in which stationary phase is highly polar and the mobile phase is low polar, hydrophobic in nature. So, normal phase stationary phase is used as silica gel, cyanotype, aminotype and diol type. These columns are comparatively costly when compared to reverse phase columns, and the solvents also highly costly. Aliphatic hydrocarbons like aromatic aliphatic hydrocarbons like hexane, benzene like and ethanol is used. Additional solvents like alcohols, ethers, etc. is also used, which should be of HPLC grade. All the solvents and mobile phases which are used in the HPLC should be of HPLC grade mobile phase, and HPLC grade water should be used. Relationship between hydrogen bonding and retention time in normal phase. Here you can see silicon type of column, the column is used which is having strong binding with the phenol. So, OH binding will be strong, which will be eluted first, and then weak steric hindrance, due to steric hindrance it will be weak and it will be eluted first, very weak bonding with the benzene and it will be eluted first. Relationship between eluent polarity and retention time in normal phase. Hexane methanol ratio, normally used solvent in normal phase is hexane and methanol. 100 is to 0, you can see 10 minutes retention time is taking the first graph, and in the second graph it takes 6 minutes when you increase the methanol ratio. When you increase further the methanol ratio to 5, the retention time is further reduced to half, that is 5 minutes itself. Then the third graph you can see 5 minutes itself, all the 4 components is getting separated. Comparison between reverse phase and normal phase. Effective for separation of structural isomers. As I said earlier, structural isomer, R isomer, S isomer can be separated, D, L isomers can be separated by using normal phase, but wide range of application is only for reverse phase, and nearly 99% of separation is based upon reverse phase chromatography. Normal phase offers separation selectively and not available with reverse phase. Stationary phase has long service life. As I said earlier, the stationary phase which used in reverse phase is less costly and has long service life. And the other thing is that the stationary phase which is used in normal phase stabilizes slowly. It takes even 1 or 2 days for stabilization, but reverse phase stationary phase like octadecylsilane ODS and decylsilane ODS, the C18 columns, it stabilizes quickly and we can finish the experiment within a day or 2, and the eluents are expensive as N-hexane and butane are costlier solvents. when compared to methanol and acetonitrile, which is used in reverse phase. Substances that should not be injected into the column. Insoluble substance should not be injected, like microscopic particles and precipitates should not be injected. The sample should be completely dissolved in the solvent or the mobile phase, then only you have to inject into the HPLC system. If the sample is not completely soluble or it gets precipitated in the methanol or water, you should not inject into the column, and you should avoid using HPLC. Substances that are precipitated in the eluent, that is what I am telling. In the mobile phase, eluent means the mobile phase. If the substance which you are dissolving is getting precipitated and it is not completely dissolving, you cannot inject into the column, because it spoils the column and it damages the column and the life of the column will be reduced. Substance that irreversibly absorb into the packaging material should not be injected, and substances that dissolve or chemically react with the packing material or the stationary phase, like acids, you should not inject acids, you should not inject chloroform into the column, it will completely dissolve the silica gel column. Okay. What is validation of analytical methods? Next, once the method is developed by using high performance liquid chromatography, you should demonstrate scientifically that the method developed for the intended purpose, that is, that errors are within a permissible range. Evaluating required items from the validation characteristics. Validation characteristics, there are different types of validation parameters are available: accuracy, precision, specificity, linearity, detection limit, LOD, LOQ, linearity, range and robustness, which is covered in the lecture given by Dr. M.K. Kadiresan in his pharmaceutical validation lecture in detail. Fields in which high performance liquid chromatography is used. Biogenic substances like sugars, lipids, nucleic acids, amino acids, proteins, peptides, steroids, amines, etc. can be analyzed using HPLC, and main usage in pharmaceutical field is to analyze the drugs and antibiotics, etc. And in food products like vitamins, food additives, sugars, organic acids, amino acids, etc. Environmental samples like inorganic ions, hazardous organic substances, etc. Organic industrial products like synthetic polymers, additives, surfactants, etc. can be analyzed using high performance liquid chromatography. This is the chromatogram of the standard cypermethrin. First chromatogram is the A, is the standard cypermethrin, and the second one is the cypermethrin pesticide, which is the residue present in the tomato samples. Tomato samples, cypermethrin, they are spraying. Tomato for growing, for the good growth of the somatostatin, their cypermethrin pesticide they are spraying. So, tomato samples are taken and analyzed. The same time cypermethrin peak is eluted in the HPLC column. So, you can find out whether pesticide is present in the natural substances which we are eating day by day in the day to day life, in the foods and the vegetables. You can analyze using high performance liquid chromatography. These are the references. First one is the Shimatsu, and second one is the Waters, third one is Skoog and West, a textbook on fundamental analytical chemistry, fourth one is Principles of Instrumental Analysis by Skoog, fifth one is Instrumental Methods of Analysis by Willard. Thank you.